Hey everyone. In this video, we're going to be continuing talking about functional groups, and we will be focusing on esters in this video. So an ester is synthesized from a carboxylic acid and an alcohol. And the functional group contains both a carbonyl and an ether or alkoxy group, but they are connected together. And so it's the C double bond O with an oxygen and then another carbon. And that's what makes it an ester. And esters are really good smelling compounds for the most part, and they're responsible for the aroma and flavor of most fruits and the aroma of a lot of flowers. Um, Typically, smaller esters are volatile, and so they evaporate easily. And so that's why you can smell them. And because they tend to dissolve in water, that's why you can taste them in your foods. And so here's a chart just showing the specific esters responsible for the flavor of certain fruits. And so the flavor of pears here is this compound, bananas is this compound, oranges is this ester, pineapples would be this one, apricots is this ester, and the list goes on and on. This would be hundreds of molecules long if we wanted to keep going. So most fruits that you're familiar with have some specific ester associated with them that's responsible for that smell and taste. So let's talk about how esters are formed. So the name of this reaction is esterification, and that's because you are forming an ester. As the name implies, esterification, formation of an ester. Now, this reaction involves a carboxylic acid and an alcohol, and they require an acid catalyst. So H plus is the abbreviation for acid, and heat. And it's a reversible reaction, so this exists in equilibrium. Now, what happens here is the OH from the carboxylic acid and the hydrogen from the alcohol combine together to make water. And what's left over here is this portion and this portion, and they get connected together as the ester. And so the carboxylic acid and the alcohol combine to make the ester, and you kick out a water molecule. So this is also sometimes called a condensation reaction because you're condensing two things together. Let's do a quick study check. Write the equation for the reaction of ethanoic acid with 1-propanol to produce an ester called propyl ethanoate, responsible for the smell of pears. So let's break this down. We're reacting ethanoic acid. Let's draw that. Eth means 2 carbons. So 1, 2, and it's an acid. So there's ethanoic acid. And we're reacting it with 1-propanol. So propanol is an alcohol. Prop means 3. So 1, 2, 3 carbons. And we're reacting it with an acid catalyst, H plus, and heat. And we are going to kick out the water here. So that will be our H2O. And we're going to combine what's remaining. So 2 carbons with the carbonyl, and that's going to be connected to the oxygen from the alcohol. And that carbon chain here is still attached. So we essentially combine this and this together as the ester. So the bond that we formed is this bond right here, the ester bond. So carboxylic acid and an alcohol condense to form the ester. And in the process, you kick out a water molecule. Let's do another one. Write the equation for the reaction of propanoic acid and methanol in the presence of heat and an acid catalyst. So we have propanoic acid. Prop means 3. So 1, 2, 3. And that's an acid. I'm reacting it with methanol. So meth means 1 carbon. So alcohol with just a single carbon, like a CH3. And this is with an acid catalyst and heat. And so we are going to, once again, kick out water, and we're going to condense what's remaining. And so this portion here is going to become attached to this portion here. And the byproduct was the water, the H2O that we kicked out. So once again, your carboxylic acid and your alcohol condense to form the ester, and in the process, you kick out the water. Okay, so now that we've talked about the reaction to form the ester, let's talk about how to name esters. So the name of the ester consists of 2 words. The first word indicates the alkyl chain that comes from the alcohol. And the second word is the carboxylate name from the carboxylic acid. So if this was the carboxylic acid and this was the alcohol, we're going to name the carboxylate portion. And so there's 2 carbons here, so this would be ethanoic acid, but the carboxylate would be ethanoate. Now, on the alcohol, the carbon chain is just 1 carbon, so that's a methyl group. And so the name of the ester formed from these 2 will be methyl ethanoate. Methyl ethanoate. Methyl from the alcohol right here. And ethanoate from the carboxylate. But you always name the alkyl chain first, so the name is methyl ethanoate. Let's do some practice problems. So how would we name the following esters? So let's break it down. We want to name the carbon chain coming off of the oxygen first. So 2 carbons, this would be ethyl. And then the carboxylate has 2 carbons, and so that would be ethanoate. So the name of this ester is ethyl ethanoate. Let's do the next one. We want to name the carbon chain first. There's 1 carbon, so that's a methyl group. And then we want to name the carboxylate second. And this has 3 carbons. So this would be propanoate, methyl propanoate. And the last one, the carbon chain here has 2 carbons. So that will be ethyl. And the carboxylate looks like it has a benzene ring. So this would be benzoate. The name of this ester is ethyl benzoate. Let's do one more practice. How would we name this ester? So this one's in skeletal form. So same process. We want to look at the carboxylate here. And it looks like there are 1, 2, 3, 4 carbons in that chain. So 4 carbons is bute. So this would be butanoate. We're naming it like it's the carboxylate. And the carbon chain here has 3 carbons. So that'll be a propyl group. So the name of this ester is propyl butanoate. All right. So now that we've named from the structure, let's see if we can draw the structure from the name. So draw the structures of the following compounds. So ethyl propanoate. So I'm going to start with the parent, the propanoate. Prop means 3 carbons. So 1, 2, 3. That is propanoate. And the ethyl means 2 carbons. So 1, 2. That is ethyl propanoate. All right, let's do the next one. So I'm going to start with the parent, pentanoate. Pent means 5 carbons. So 1, 2, 3, 4, 5. That is pentanoate. And the alkyl chain is butyl. Bute means 4 carbons. So 1, 2, 3, 4. That is butyl pentanoate. Okay, now that we've talked about how to name these and we've talked about how to form them, let's talk about how to destroy them, essentially. And so a new reaction that we're going to learn about is called hydrolysis. And there are 2 parts to this word. Hydro means water, and lysis means to cut open. And so we are going to be using water to cut our ester open, essentially. Now, we are going to be breaking the ester bond right there. We're going to be slashing that in half right there. But in order to do so, we have to reinsert a water molecule. And so we're going to break a water molecule open. Water is H2O. So you can think of that as H and OH. And so where we cut these, the hydrogen will combine with the alcohol side, give us the alcohol back. And the carboxylate side will combine with the OH from the water to make our carboxylic acid. So the ester gets cut open with water to give you the carboxylic acid and the alcohol. And so this is essentially the reverse of esterification. Let me scroll back to that earlier slide. So esterification is forming the ester, where you have the acid and the alcohol combining. Hydrolysis is destroying the ester. So you break it open and you go back to the acid and the alcohol. And to do this, we need acid and heat as the catalyst. And so because this is a reversible reaction, we call one way esterification, we call the other way hydrolysis. So forming the ester is esterification, breaking the ester is hydrolysis. Now, this is under acidic conditions because we're using an acid catalyst. It's also possible to do hydrolysis using base, and we also call this reaction saponification. But essentially, it's base catalyzed hydrolysis. And so we will be using a base, in this case, sodium hydroxide. The same general process happens. We are cutting the ester open, but we're not using water, we're using a base. And so instead of H2O, we have NaOH. We still get the hydrogen combining with the ester to make the alcohol. But now we have ONA, which combines with the carbonyl side to make the carboxylate salt. And so that's the key difference between acidic hydrolysis and basic hydrolysis. Under acidic conditions, you get the carboxylic acid. Under basic conditions, you get the carboxylate salt as the product. Okay, so let's do some practice with these. Write an equation for the reaction of methyl acetate with water, heat, and an acid catalyst. So let's start with what we're given, methyl acetate. And this is the common name. The IUPAC name for this would be methyl ethanoate. So acetate and ethanoate are the same thing. So that would be ethanoate. And then methyl means that there's just one carbon coming off the oxygen. So that's methyl ethanoate. And we're reacting it with water, so H2O. And we're using an acid catalyst and heat. So we're going to be breaking our ester open. And we're going to be breaking the water open. Oops. And those are going to recombine as our carboxylic acid. And the other portion here is going to combine with the hydrogen, and that's going to give us our alcohol. Okay. So we cut the ester open, reinsert the water, and we go back to the carboxylic acid and the alcohol. So this is acid hydrolysis. Now, let's do the same equation, but using KOH and heat. So base hydrolysis. So same starting molecule, methyl acetate, but this time we're reacting it with KOH and heat. So similar process, we cut the ester open. And that's going to give us our carboxylate salt. It's going to be O minus K plus. And then the other thing we're left with is going to be our alcohol. Oops. So once again, uh, we're going to be cutting the ester open using a strong base. We end up with the carboxylate salt and the alcohol. So because we don't have water, we have KOH. One side gets the KO, the other side gets the H. This is base hydrolysis versus acid hydrolysis. So that concludes this video on esters. Thanks for watching, and I'll see you in the next one.